Well, hello everyone. I'm creating a video here, a lecture video that I hope is fairly brief, but starts to get us into the material out of chapter 3, talking about physical and cognitive development. And what we're going to be looking at here is development, both physical and cognitive, from infancy and toddlerhood. So be thinking from the point of birth to about through age 2, age 3 in that regard. So let's go ahead and get you started. One of the first things that I want to talk about in terms of physical development after birth is the concept of the reflex. Now, reflexes are voluntary movements. They basically are designed for a number of different purposes. One, they are designed to protect us. That pretty much goes without saying. They are also, too, designed to help us find sustenance, food, drink, and things like that. And as we go through these, you'll see how a lot of these work. Most reflexes that infants and toddlers have are usually caused by external forces. Something out there happens to make these take place. And I'm going to go through these now and then include some links to some video so you can see some of these things in action. Be aware of this, and I want to say this before I begin. Reflex and the study of reflexes is not just something that's cute. Let's see what babies and toddlers will or will not do. But please note the following, and this is very important. The presence of reflexes, all right, the fact that maybe reflexes never appear or that reflexes do not go away, or the fact that certain reflexes reappear when you think you should be done with them, and I'm not going to worry too much about the times and dates of when things are supposed to be done, can be a sign of internal problems, okay? Problems with the central nervous system and things like that. So, and you'll hear that mentioned in the videos. The absence of reflexes, the continued presence of reflexes, that they don't evolve away over time, or the reappearance of reflexes after a point at which they should be gone, can be a sign of internal neural networking issues within the baby, okay, and the toddler. So keep that in mind. Let's get started. The first one I want to mention here is called the blinking reflex. And quite honestly, the blinking reflex is the one reflex that stays with you for a lifetime, okay? A lot of these will disappear, but these involuntary movements, this one stays with you. A puff of light, a puff of air, a bright light, something like that in one's face will cause an infant and even an adult to close their eyes. It's a form of protection. I say again, of all the different reflexes, this is the one that seems to stay with us all the time, okay? There's the grasping reflex. If you have a son or daughter, if you have a baby brother, baby sister, if you're taking care of an infant, you will find sometimes that if you turn around, I'll show it here, and you basically put your finger in the palm of their hand, that they'll grasp your finger. And believe it or not, this grasping reflex can be so strong that if you start to gently and slowly pull your hand upward, all right, they'll hold on. They'll take it right with them, and so on and so forth. You can almost pull them upwards a little bit before it's too much. The grasping reflex does disappear after a number of months. Once again, we're not going to get into that, but it's basically a design method. If something touches their hands, they grip it. All right. It's designed for protection, keep them from falling. That's what we theorize. The Moro reflex is a little bit harder to explain. What happens with the Moro is that when a baby turns around and is dropped from a very, very short distance, maybe you hold them up about an inch off the pick up the shoulders, their bottom is still on the table, bring them up about an inch, and you sort of let them go. They really don't fall, but very far at all. But in the process, what they do is that they throw out their hands as if they're trying to catch something, and then they pull in tight as a means of protection. Okay, you see this first reaching out to grab and then preparing for the fall and things like that. This usually disappears within 6 to 9 months. Once again, I'm not holding you to the time, but it's meant as a preservation reflex, and it's built into them. The rooting reflex is based off the premise and the idea of feeding. And you see this very early in infancy. If you turn around and you stroke the side of the mouth of an infant, they will turn in the direction of the stroking, and this sometimes will follow what is called the sucking reflex, which if you turn around and it's your finger or something, they'll start to suck on it as if it is a mother's breast for feeding purposes. The stepping reflex is a fascinating one. You'll have to watch the lecture video to see this. But if you hold an infant, especially a newborn, up right, and you touch their feet against a table or a flat surface, they will start to pick up their feet as if they're walking. Sometimes if you hold them and you touch what would be the top of their foot against something, they'll start to raise their feet as if they're trying to step up a set of stairs. They don't have the physical strength to do that, but that seems to be an inborn ability. This is one that I'm going to tell you, don't ever, ever, ever try, period. Okay? And I'm not kidding. It's the swimming reflex. What they have found is for an extremely short period of time, if an infant is submerged in water, don't ever try it. Basically, they will hold their breath and they will start to kick and to move their feet and their legs and things of that sort. All right? Basically, it's just a survival method, but obviously it can only last for seconds, and even then I wouldn't recommend it. Don't want anybody leaving the class saying Dr. Gambin suggested we do this. No, Dr. Gambin did not suggest that we do that one. I mentioned before the rooting reflex, and then there is the sucking reflex. If you turn around and you give an infant a bottle or something near their mouth, they will start to suck on it as if it is a form of feeding. And so that is designed, obviously, for sustenance. And then probably one of them that is one of the most amazing one is called the tonic neck reflex. I'll include a video of this, but basically what will happen is this, that sometimes you see it more when an infant is sleeping. They will turn around and if you turn their head in one particular direction, what they will do is they will take their arm, as you see in the picture there, and extend that arm straight out, and then they pull the other arm closer to their body, okay? And then if you turn their head gently, especially when they're sleeping, they'll reach out the other arm, that was close to their head or their body out, and they'll pull the other one in. This is something called the tonic neck reflex. It's also called the fencer's pose. That's an interesting question. Which one is also known as the fencer's pose? Because when you're fencing with a foil, some call it a sword, but with a foil, you usually turn around and keep one arm in close and the other arm has your foil in your hand, and you're fencing. So basically you'll see what I'm talking about in the lecture video, in the video that I include. So these are some of the reflexes. Do keep in mind their purpose is for feeding and protection, and that the presence of some, the absence of some, or the reappearance of certain reflexes can be a sign that there is neurological problems within. All right, before we get done, let me turn around and I want to share with you a quick little discussion of brain development. Remember, we're talking infants and toddlers here. And one of the things that I find most fascinating about babies is this. When babies are born, Believe it or not, their brain is not done developing. So you get that? When a baby is born, their brain is not done developing. All right? There are a lot of neural pathways that still need to be created. All right? And so what happens is that those neural pathways seem to develop while an infant sleeps. Some newborns can sleep upwards of 16 hours a day. They sleep, they wake up, they turn around and basically, feed and stuff like that, and then they do it again. They go back to sleep. Research has told us that the brain of a newborn and even an infant will turn around and continue to develop neural pathways basically while they sleep. That's why even children, small children and toddlers, as well as infants, need a lot of sleep because it's during that time their brains develop. I've told students, and it's very important, if you have a newborn, let them sleep. Okay, they need their sleep. It's very, very difficult to try and get a newborn on a normal sleeping schedule. And I would honestly propose you don't do that, at least not for the first couple of months, because basically, while it's very hard on mom and dad, trust me, I've been there, that brain is developing during that time, and that is very, very important. We talk about what's called REM sleep, rapid eye movement. That's when most of these neural pathways are developing. So if a child is born premature, that's all the less brain development they have, and that's why sleep is so very, very important. As these neural pathways are developed over months, if not the first handful of years, the brain, it's sort of amazing to me, the brain turns around and overdevelops neural pathways. You got that right. It overdevelops neural pathways, and that is by design. As time goes on, at age 2, at age 5, at age 7, at age 10 and 14, the tremendous number of neural pathways begins to degrade. And the ones that are the newest stay, and the older ones are basically, they die away. It's not a bad thing. It happens to all of us, okay? This is called programmed cell death. This is in the brain, and it is a fantastic way for the brain to make sure that it is creating the best neural pathways. In fact, one of the terms used is called pruning, okay? If you've ever had a plant, and you notice that some of the limbs and the stems once in a while die, the best thing to do is to turn around and remove them, to get them out of there. It makes way for newer parts of the plant to come to life and thrive. The human brain in an infant and toddler and even a small child does the same thing. It develops and overdevelops in the beginning, but then programmed cell death starts to occur, and neural pathways that were used in the beginning are abandoned, and the brain just automatically prunes them away and gets rid of them and replaces them with better ones. I'll show you an example of that in a photo here in the next slide. But before I go to that, I want to mention the term known as plasticity. Plasticity simply means this: the younger an infant or toddler is, the easier it is for them to develop new neural pathways, to repair damages to the brain than it is in people such as you and I, okay? This is what plasticity is all about. The younger we are, the more our brain is able to fix and reroute and go around damage and reset itself. For really young infants, I mean, of course, there's a point where you cannot fix things, but if there is a little bit of damage, and damage isn't really the right word, the brain can get around things, okay? The brain can fix things. As you get older, the neural routes through the brain are pretty much solidified, plasticity ends, and by the time you're in mid to late childhood, even adolescence, a lot of your brain has hardened in that regard, and easily making new routes and easily repairing damage is no longer the case. And once again, no disrespect for you nor I, if we have any kind of moderate to severe brain damage at the age we are now, we're not going to have the opportunity for good repair like an infant might be able to have. So that's something that works to our disadvantage. So plasticity happens. The younger a child is, the easier it is to fix and repair small to moderate, I don't want to overdo that, damages to the brain. And then basically, as we get older, the brain loses its plasticity and can't do that. Now, the last thing I want to show you here is an example of neural pruning. This is a picture actually taken with a very fancy microscope and things like that. And basically what I wanted to point out is this. As you see there to the left, at birth, the neural pathways of an infant is very, very limited, okay? By 6 years old, it looks like a scattered mess. That is the neural pathways, the synapses overdeveloping, and that's by design. But as they get older, all right, pruning has occurred, all right? It is programmed cell death. And the idea is that by the time you get to be your teenage years, your neural pathways have been cleaned up. The ones that are used are present. The ones that no longer are used have been wiped away. Okay, so these are some of the facets of physical development, talking about reflexes, talking about the importance of sleep in a newborn to allow neural pathways to develop, and how the brain deals with issues such as plasticity, overdevelopment, and pruning at later times. Hope that all helps. Take care.